Hello guys, welcome back to my channel. In our today's tutorial, I'm going to show you on how to subtract the binaries using the one complement. If you look at the other video that I'd already shown you on how to work on the binary addition, and unlike the addition, the case of subtraction is quite different, and this is how to go about it. But before we go to the steps on how to subtract the binaries, you need first to get yourself conversant on how to work with the binary addition. For example, 0 plus 0 for the binary addition is supposed to give you 0, while 1 plus 0 is supposed to give you 1. 0 plus 1 is supposed to give you 1, while 1 plus 1 should give you 1, 0. Remember, this is binary addition, not the normal numbers. Therefore, we have to state it as 1, 0 and not 10. Then the other thing, we have 1 plus 1 plus 1 is supposed to give you 1, 1. But we also have another scenario whereby we have 1 plus 0 plus 0 plus 1. It should give you 1, 0. 1 plus, when you had 1, then you had to 0, then you had to 1, it should give you 1, 0. I hope we are together on that. Okay, let's move now to the next part on how to subtract the binaries using the one complement. And guys, before we dive into the whole thing, if you are new on this particular channel, don't forget to subscribe. And for those who have already subscribed, don't forget to share with your friends who are facing the same challenging on the challenges on how to work on the binaries, either addition, subtraction, conversion from one format to the other. So these are the steps. So step number 1, you need to ensure that both numbers have the same numbers of bits by adding zeros to the left of the number with fewer bits. I hope that's clear. Then step number 2, you generate a one complement of the negative number. Then step 3, you add the generated value to the positive number. Then number 4, if the answer obtained has more bits than the original number, the extra bit is known as the overflow. This particular one is our overflow. This, you need now to take these particular bits to the least significant bits of the answer. Then lastly, if the answer obtained has the number of bits similar to the original number, then you adapt that as the final answer. Okay, having done that, now let's move now to our example. Okay, so our first example, we have, let me try to minimize these so that we can have, okay, I think that's better. Okay, for this one, I will try to drag it up to that point. So for this particular case, we have 0, 0, 1, 1. Okay, we need to remember the rules. The rules for this one is that you need first to ensure that both numbers have similar number of, they have a similar number of bits. Therefore, for this one, we will have, if you look at this one, the number of bits that we have is 2. Therefore, now we need now to add the 0 so that we have equal number. So we'll have 0, 0, 1, 1, 2, 0, 0, 0, 0, 1, 2. So we have equal number of bits. This is 0, 1, 1, 0, 0, 1, 1. Okay, having that, we move now to step number 2. Step number 2 is to generate a one complement one's complement of the negative number. Now what that means is that for this one, this section 2, this one complement will translate to, whenever we have a 0, you change it to 1. Whenever we have 1, you change to 0. Therefore, for this one, it will be 1, 1, 1, 0. So we have changed the 0 to 1, well, 1 to 0. Okay, after that, the next step is to go now to addition. We move now to step number 3. You add the generated value to the positive number. So we have 0, 0, 1, 1 plus 1, 1, 1, 0. Remember the rules? 1 plus, this is addition, you had 1 plus 0 is always 1, while 1 plus 1 is 1, 0. So you write the 0 here. Then the next part, you carry the 1 to this part. So we have 1, 0, 1. 1 plus 0 plus 1 is equivalent to 1, 0. Therefore, you write these as 0. Then you carry 1 to this point. 1 plus 0 plus 1 is equal to 1, 0. Now that one takes us to rule number 4. If the answer obtained has more bits than the original number, the extra bit is known as the overflow. So this is our overflow. So this one is what we call the overflow. Now you take this one and you add it to the bits. So you take this one, so the answer, which is this one, I will take this one and I will add to 0, 0, 0, 1. The answer that we had in our previous case on the top here. Then you add with the overflow. Now, after you add to the overflow, what we will have next is you will add 1 plus 1, which is 1, 0. Now, carry 1 here. 1 plus 0 is 1. Then the other is 0, 0. Therefore, the final answer for our case is 0, 0, 1, 0. And that is how we subtract our binaries using the 1 complement. I hope it's that simple and very clear. So as long as you are able now to interpret the steps, or rather to follow the steps from step 1 all the way to the last step, you will find that the answer will be correct. So you will also come another scenario whereby the answer obtained will have a similar bits as the original number. Therefore, the answer that you get will be the final answer. Okay, let's move to another scenario for practice purpose, where we have 1, 1, 0, 1, 2 minus 0, 1, 1, 1. Okay, for the purpose of, okay, let me take you to this other one so that you can also compare, so that as I try to make the calculation, we'll be able to make the follow-up. Okay, remember the rules. Step number 1 is to convert this section into 1 complement. So for this one, the complement for this one will be 1, 0, 0, 0, 2. Okay, therefore we'll have 1, 1, 0, 1. While the other one is 1, 0, 0, 0. Okay, so you had, remember the wholes. You can as well as try to compare with the theson. Be looking at these. 1 plus 0. 1 plus 0, as you can see, is supposed to give you 1. 0 plus 0 is 0. 1 plus 0 is 1. Okay, let me try to wrap this out. This is supposed to be 1, while 1 and 1 is supposed to give you 1, 0. Theson. Now, if you look at the original number, we had 4 bits, but for our next case, we have 5 bits. So remember what we had already done on the other previous case. So what you're supposed to do, you carry to the least significant bits. That is 0, 1, 0, 1. So what I've done, I have exempted this one. I will exempt this one, then I will add it here. Well, these are the keys. This is what we have at the top. So what I will need to do is to add the 1 here. So what I'll have, 1 plus 1 is, then carry 1. 1 plus 0 is 1. Then 1 and the other one is 0. So our final answer, is 0, 1, 1, 0, 2. That's simple. Okay, I hope you have understood how to work on one complement. Okay, let's do our last example. Okay, our last example, which is quite simple, we have 1, 0, 1, 0, 1, 1, 1. Remember, the rule number 1 is to convert this one into a one complement. So how do you work with one complement? You have to convert these, after convert this one, it will be equivalent to, okay, so it will be equivalent to 0, 0, 0, 0, 0. Then after that, you go direct now to the addition. 1, 0, 1, 0. Then we have 0, 0, 0, 0. Then you had 0 plus 0 is 0. 1 plus 0 is 1. 0 plus 0 is 0. 1 plus 0 is 1. It is that simple. So the final answer for our case is 1, 0, 1, 0, base 2 is our answer. So it is that simple. So that is the end of this particular case. So in our next lesson, we will cover subtraction using the two complements. So in case you are having any challenge with any particular number, you can write it down on the comment section. I will get back to you. You need to get yourself conversant for in the addition so that you can apply the same methods to do the subtraction. So these are the most basic arithmetic addition in binary addition. For example, 0 plus 0 is always 0, while 1 plus 0 is equal to 1, 1 plus 0 plus 1 is equal to 1, 1 plus 1 is equal to 1, 0, while 1 plus 1 plus 1 is equal to 1, 1. And lastly, 1 plus 0 plus 1 is equal to 1, 0. So as long as you are able now to interpret all these basic arithmetic addition in the binary numbers, you'll be able now to do all the subtraction that exist. Okay, So in the next part, we are going to look at the binary subtraction using the one complement. But for this particular one, we are going to use the two complement methods for the binary subtraction. So step number one, you need to ensure that both numbers have the same number of bits by adding zeros to the left of the number, not the key part, left of the number with fewer bits. So the bits are supposed to be the same. If the first number has 4 bits, the other number is also supposed to have 4 bits. So in case the number has less bits, you need now to add zeros to the left hand side. Okay, step 2, you generate a one complement for the negative number. Then you add the generated value to the positive number. Then step number 4, you add 1 to the generated value to get two complements. You add 1 to the generated value. You add 1 to the generated, because that's the most important part. You add this one. You had this particular part. You had 1 to the generated one. Then you had the two complement. You had the two complements. If the answer obtained has more bits than the original number, the extra bit known as the overflow is always excluded from the answer, because also this is also very key, because we might have another scenario whereby you have more bits than the original number. Then lastly, if the answer obtained has the same number of bits, you retain the answer. Okay, having done that, now let's move to our example. Okay, let me try to minimize this one so that we can apply the same concept to work on it. Okay, I hope you are able to see that font. Okay, so our scenario number 1. Okay, let me do this. Okay, I hope you are able to see. Okay, so number 1, we have this one. We have 0, 0, 1, 1 and 0, 1. Remember the rules? If the bits are less, you need to do what? To add extra zeros to the left. And as you can see, on this one, we have 2 bits, while the other one we have 4 bits. Okay, let's try to do that. And also guys, as you continue to watch, if you are new to my channel, don't forget to subscribe. Continue supporting me by subscribing and also sharing to your friends who might be experiencing the same challenge on how to add the binaries, and also at the same time maybe on how to add or to subtract. Okay, so what you have, step number 1, you need to add the extra 0 for this one. So for this one, I will highlight this one. So I will add more zeros. Therefore, we'll have 0, 0, 0, 1. So the first one in the next group, we have the same number of bits, 4 and the 4. This is 4, while the other one is 4. Okay, step number 2, you generate the one complement of the negative number, and this is my negative number. So this is my negative number. So the one complement, you need now to go back to the other video that I've prepared. Whenever we have 0, you convert to 1, where the 1 it's converted to. So for this one, this is a negative, this is a negative 1, it will be 1, 1, 1, 0. So what we have done, we have generated a one complement for the negative number, and this was our negative number, which was 0, 1. So far we are at step number 2. Okay, let's move to step number 3. You add the generated value to the positive number. You had 1, 1. So what am I supposed to do? I will have this generated number. I'm still working with this one. 1, 1, 1, 0 plus 1. Remember the rules? Whenever we have 0 plus 1, it's supposed to give you 1. Therefore, the answer will be 1, 1, 1, 1. Now we are at now step number 3. So we have added, no, sorry for that. We are at, we have added 1 to the generated value. 1 to the generated value. Okay, let's move to the next part. Now, our next generated part, we have to add the two complement number. So our number, this one, which is a 0, 0, 1, 1. Well, this other one, which is 1, 1, 1, 1, plus. We are trying to add. Now, we need to remember the rules of addition. 1 plus 1 is equal to 1, 0. Therefore, you write 1. After you write 1, you carry 1, the one that is remaining, you carry it above. Okay, let me draw a line here to separate. So we have 1 here. So 1 plus 1 plus 1 is 1, 1. So we'll have 1 here. Then you have another one there. Then we have 1 plus 0 plus 1 is equal to 1, 0. Then you write 1. Then you carry that other one to above there, where we will have 1 plus 0 plus 1, which is equivalent to 1, 0. Then you write it as 1, 0. So our answer is 1, 0, 0, 1, 0. After adding 0, 0, 1, 1 plus 1, 1, 1, you get 1, 0, 0, 1, 0. Okay, having done that, rule number 5, it says that if there's an extra bit, which is now known as the overflow, this one, this is our overflow. So if you have an overflow, unlike the case of one complement where we are supposed to add, for the case of two complements, you are supposed to exclude it. Therefore, the final answer will need to exclude the extra bits. Therefore, my final answer will be 0, 0, 1, 0, 2. That is our answer. So what we have done, we have excluded the 1. Hope up that to that point we are together. Okay, let's do our example number 2 so that you can get yourself conversant on how to do the whole thing. Okay, our example number 2, we have 1101 base 2 minus 111. Remember the rules? If the bits are less, you add. So for this one, for the negative one, for this one, we have this one. I will add and be okay. So we have for this one, we will have 0, 1, 1, 1. Then the next step, this one we convert it into one complement, and one complement, whenever we have 0, it's 1. 1 is 0. So for one complement on this one, it will be 1, 0, 0, 0. Okay, after doing that, still the number that we have, we need to add to two complements. So you add this number to 1. Therefore, the answer that I will have 1, 0, 0, 1. Remember the rules? 0 plus 1 is 1, while 1 plus 1 is 1, 0. Okay, having gotten that, now you go now to the normal addition, which is 1, 1, 0, 1 plus 1, 0, 0, 1. So this 1 and 1 plus 1 is equal to 1, 0, carry 1. 1 plus 0, you get 1. 1 plus 0 is equal to 1. Then we have 1 plus 1 is equal to 1, 0. So we have an overflow. So for the overflow, the rules are very clear. We exclude it. You need to exclude it from the working. So I will exclude this one. Therefore, my answer will be 0, 1, 1, 0. Base 2. So this is the answer. Okay, let's move now to our last example. Maybe I might give you, you can have maybe 2 minutes to go through this one so that you can gauge whether you have understood. 2 minutes. So 1 minute is over. Okay. Okay, let's do it now. So we have our case is remember the rules for this one. You convert it into one complement, and for the one complement, whenever we have ones, you convert to 0. So for one complement, this is a one complement, you will have 0, 0, 0, 0. Then for the two complement, it's supposed to be 0, 0, 0, 0 plus 1, which is equal to 0. The answer will be 0, 0, 1. Now, after you get that, now you add with to the positive number, and our positive number is 1, 0, 1, 0 plus 0, 0, 0, 1. Then you add this one plus this one, you get 1, 1, 0, 0, following the rules of addition. Therefore, our final answer will be 1, 0, 1, 1 base 2. So it is that simple on how to add, or rather to add and the same time to subtract using the two complement methods. Hope up to that point you have understood on how to work with the two subtraction. We have already looked at the other scenarios. For example, we had already looked at the binary addition, binary subtraction using the one complement, and the binary subtraction using the two complements. But for this specific video, I'm going to take you through the directory subtraction of the binaries. Okay, before we dive to the whole thing, we need to remind ourselves on the possible basic arithmetic addition, which is mostly used on both the addition and the subtraction. For example, 0 plus 0 is always 0, 1 plus 0 is equal to 1, 0 plus 1 is equal to 1, 1 plus 1 is equal to 1, 0, 1 plus 1 plus 1 is equal to 1, 1, while 1 plus 0 plus 1 is equal to 1, 0. But for this other scenario where we have the direct subtraction of the binaries, these are the possible basic arithmetic addition, and subtraction is supposed to be rather subtraction. Sorry for this. It's supposed to be subtraction. Supposed to be subtraction. So if you look at the first scenario that we have, subtractions, we have 0 minus 0 is equal to 0, while 1 minus 1 minus 0 is equal to 1, and lastly, whenever you subtract minus and minus, you get always 0. So for 0 and 0 is equal to 0, 1 and 1 is equal to 0. But when we have 1 minus 0 is equal to 1. Okay, having done that, let's move now to the example so that you can practice using the principles that we have highlighted here. So we have our first example where we have 0, 1, 1 is base 2 is equal to minus 0, 1 base 2. So we are supposed to subtract this one from the other side. Okay, let me create two screens. so that we can make our work easy and do this. Okay, so these are the possible subtraction. Sorry. So we have 0, 0, 1, 1, and 0, 1 base 2. Remember the rules. If the number of binaries are not equal on both sides, you need to add zeros on the left hand side. For example, for this one, we will have, for this scenario, we will have 0, 0, 0, 1. Therefore, our next equation will have 0, 0, 1, 1 base 2 minus 0, 0, 0, 1 base 2. So this is that part. So what we have actually done is that we have added 0 on the left hand side so that we can have equal number of binaries of the two numbers. These are 4. As you can see, these are 4, while these other one are also 4. Okay, let's go now to the direct subtraction, where we have 0, 0, 1, 1, while the other one is 0, 0, 0, 1 over minus. If you look at the instruction that we have, whenever you subtract 1 plus 1, 1 minus 1, for example, this one, 1 minus 1 is always 0, so you write 0. While 1 minus 0 is, as per this rule, 1 minus 0 is always 1. Then we move to the other part. 0 minus 0, as per the rule number 1, is always 0, while 0 minus 0 is 0. Therefore, we can conclude by saying that our final answer, will be 0, 0, 1, 0 base 2. It is that simple. As long as you are able to interpret these basic subtraction rules, you'll be able to get everything correct. So this is correct. I hope up to that point we are on the same part. Okay, let's move to our next example, where we have 1, 1, 0, 1 base 2 minus 1, 1, 1 base 2. Remember the rules. Number 1 is to ensure that the number of binaries are equal. If you have 4 binaries, the other side should always have 4, so that they are equal on both sides. So for you to ensure that the both sides have equal number of binaries, you are supposed to add zeros on the left hand side. Therefore, for this particular case, I will have this one, I will add zeros. Therefore, we will have 0, 1, 1, 1, and 2. So that our question will be 1, 1, 0, 1 minus 0, 1, 1, 1 base 2. So if you look at the two scenarios, the number of binaries are equal on both sides. Okay, let me give you now maybe 2 minutes so that you can attempt following the rules, the 3 rules. Okay, 1 minute remaining. Okay, let's do it. So we have 1, 1, 0, 1 minus 0, 1, 1, 1. So we have that scenario. Create another space there. Now let's look at our rule number 3. 1 minus 1 is always 0. So this is definitely like that. So this is sorted out. Okay, let's move to the next digits. We have 0 minus 1. Remember, 0 is less than 10. Therefore, we will borrow 1 from the immediate left value to have. So you will borrow this one, this part, so that we have, after we borrow 1, we will have 10 base 2, which is the same as 210. Now, it means that we'll have 10 minus 1. Not 10, but 1, 0 minus 1, as per the rule, is equal to 1. So whenever you subtract 1, 0 minus 1, you will get 1. Therefore, I will write 1 here. Now let's move to the other part. Now, since we borrowed 1 from the immediate left, the new value is 0. So here we have 0 after we borrowed the 1. So the new value is 0. Therefore, if the new value there is 0, it means that we borrow, we carry this one. The one on this part, we carry the to 1, 1. So we'll have 1, 0 minus 1, which will give us 1. So we'll have another 1 here, meaning that after we borrowed the 1, we remained with 0. Now this one takes us to the rule. This rule, 0 minus 0 is equal to 0. Since we borrowed the 1, it remains with the 0. Therefore, we have this 0 minus the 0, we get 0. Therefore, our now answer for this one will be the answer that you're supposed to give to your lecturer is supposed to be is equal to 0, 1, 1, 0 base 2. So this is the final answer for our case. So the most important part on the direct subtraction is that as long as you're able to get the possible basic subtraction principle, that is 0 minus 0 is equal to 0, 1 minus 0 is equal to 1, and 1 minus 1 is equal to 0. You'll be able now to get all the working correct. Okay, so in case guys you have more example or any challenging part on the either binary addition or the direct or the binary subtraction, you can reach out to me through the comment section. Just write down your question that is challenging you, or I will get back to you. And also guys, don't forget to subscribe, share this work with your friends. You can also watch other videos that have explained on how to add the binaries, on how to add the or rather on how to subtract binaries using the 1 complement and the 2 complements. Thank you for taking time to watch. I hope you have learned something. Bye bye. Don't forget to subscribe. We'll meet another day.